Okay, welcome. In this short video lecture, we are going to discuss on how to find or how to evaluate special integrals using beta functions. My name is Vincent. I teach in School of Engineering at University of Nairobi. So this is a problem. To use beta functions to compute the integral 1 to 3 t minus 1 raised to power 10, t minus 3 raised to power 3 dt. So what we do in this given problem, the first thing we have to define beta function, which is given by beta function with parameters m and n, x raised to power m minus 1, 1 minus x raised to power n minus 1 dx, and can also be given in terms of gamma function. And when m and n are integers, then this can be written as m minus 1 factorial, n minus 1 factorial divided by m plus n minus 1 factorial. So what we have here, the integral 1 to 3 of t minus 1 power 10 into t minus 3 raised power 3 dt is not in this form. So what we do, we have to get a transformation or retransform the integral in terms of a different variable, not t, that will ensure that limits are from 0 to 1, and the structure of the integrand here is of this form. We can achieve this one by letting a new variable x to be the same as this part t minus 1 over 2. I remember the new variable introduced or the new transformation that you do should ensure that also limits are adjusted so that they conform to the standard form. So let's check whether this will work. So as t approaches 1 from what we have here, then x approaches 1 minus 1 over 2, which will be 0 over 2, which is 0. And that is what you expect to get. And then as t approaches 3, then this x will approach 3 minus 1 divided by 2, which will mean we have 2 over 2, which is 1. So this transformation will actually ensure that our limits are now converted into standard form. Now, this one means that 2x equals to t minus 1, which tells us that 2 dx equals to dt. So where there's dt here, we can replace by 2 dx. And then therefore, this integral will be, and then you can easily see from this part that t is nothing but 2x plus 1. So where there's 2, we replace by this. Where there's t minus 1, we replace so where there's dt, we replace by 2 dx. So this will be integral now from 0 to 1 of where there's t, put 2x plus 1, and then minus 1 raised to power 10 into 2x plus 1 minus 3 raised to power 3, and then where there's dt, you put 2 dx. so that this will give us 0 to 1. So this will be just 2x raised power 10 because minus 1 and plus 1 cancels out. And then this will be 2x minus 2 raised power 3, then times 2 dx. And then from this one here, you can see that we'll have 0 to 1, 2 raised power 10 times x raised power 10 times 2, this 2 here, and then times, I can write this one as minus 2 into 1 minus x power 3 dx. I hope you see that this and this are still the same. And then this is the same as 0 to 1, 2 power, so 10, this like power 1, so power 11 times x power 10 times, so this will have times minus 2 power 3, and then 1 minus x power 3 dx. So which will be now 0 to 1. So this the same as 2 power 11 times minus 2 power 3 times x power 10 into 1 minus x power 3 dx. So we factor out minus 2, so this will be 14 integral 0 to 1 x power 10 into 1 minus x raised power 3 dx. You should be smiling because where we are going, the integral is changing into the structure of a beta function. So this would be minus 2 raised power 14, and then 0 to 1. Then I can write this one as 11 minus 1 into 1 minus x raised power 4 minus 1 dx. And if you check this one clearly, what I have here, this one actually is in the form 0 to 1, x raised power m minus 1, 1 minus x raised power n minus 1, then dx, which is the structure of a beta function with parameter m and n. So then, and we know its value the same as gamma m, gamma n over gamma of m plus n. So therefore, this we can write it as negative. So this case, when you compare this one with this standard one, so m is 11 and n is 4. So this is the same as negative 2 power 14, then beta of 11, 4. So which is the same as minus 2 power 14, gamma of 11, gamma of 4, and then over gamma of 11 plus 4. So this minus 2 power 14 times 11 minus 1 factorial times 4 minus 1 factorial. And then 11 plus 4 is 15, so 15 minus 1 factorial. So therefore, we have minus 2 power 14 times 10 factorial times 3 factorial, then times 14 factorial. Then you can always simplify and get the answer to that given part to get the answer from a calculator. So that is how we solve that problem. Similarly, if we have a problem with the form, if you are also asked to evaluate the integral, say number 2, evaluate integral from 0 to 1 of x power 4, and then square root of 1 minus x squared dx using beta functions, then this is how we work it out. For this one, you see that actually the limits are okay, but the problem is here. So then you say integral from 0 to 1 of x power 4 square root of 1 minus x squared dx is the same as 0 to 1 x power 4 and then 1 minus x squared raised power half. You know the square root means raised power half. That is step 1. And then step 2, we fix this part. So we say let u to be x squared so that x alone is the same as square root of u, and du equals to 2x dx, which tells us that dx equals to du over 2x, which is du over the square root of u times 2. And then actually our transformation works because as x approaches 0, then u approaches 0 squared, which is 0 as required. And then as x approaches 1, then u approaches 1 squared, which is 1, so it's okay. So we have this transformation still retains the limits to be 0 to 1. So we rewrite the integral as 0 to 1 of, so where this x we put root u, and then this will be power 4, and then 1 minus u, because already x squared is u from our transformation raised power half. And then where there's the x, we put du over 2 square root of u. Now, this will give you 0 to 1. This, when you raise to power 4, you get u power half, 1 minus u raised power half, and then I can factor out a half here, but then there's u raised power half, this root u du. So using, so remember this is times 4. So this would be a half u power 2 over u power half into 1 minus u raised power half du. And using laws of indices, we'll have a half u raised power 2 minus a half into 1 minus u raised power half du, which will be a half integral from 0 to 1 of u raised power. So 2 minus a half will give you 3 over 2 into 1 minus u over raised power half du. And you see this part here, this part. Conforms to this general form x raised power m minus 1, 1 minus x raised power n minus 1 dx, which defines the beta function of with parameters m and n. So you can write this one as a half integral 0 to 1 u raised power 5 over 2 minus 1, which is give us 3 over 2 into 1 minus u raised power 3 over 2 minus 1 du. So it tells you that m is 5 over 2 and n is 3 over 2. So so we'll have a half beta of 5 over 2, comma 3 over 2. And when you write this one in gamma form, will be gamma of 5 over 2, gamma of 3 over 2, and then over gamma of 5 over 2 plus 3 over 2. So we use the property that gamma of x plus 1 equals to x gamma of x, then which means gamma of x equals to gamma of x plus 1, this property of gamma function. So to evaluate gamma of 3 over 2, gamma of 5 over 2 is the same as gamma of 3 over 2 plus 1, just using this property, which is the same as 3 over 2, gamma of 3 over 2. And then 5 over 2 plus 3 over 2 is 8 over 2, which is 4. So therefore, here we'll have a half 3 over 2, gamma of 3 over 2 times gamma of 3 over 2, and then divided by gamma of 4. This comes to this. And gamma of 3 over 2 is the same as gamma of a half plus 1. So which is the same as a half gamma of a half using this property. So which is the same as a half square root of pi. Since gamma of a half, we know the answer is root pi. So this will be now a half times 3 over 2. So the place of this one, we write a half square root of gamma times a half square root of pi square root of pi. So gamma of 4, using the property gamma of x equals to x minus 1 factorial, will give us 3 factorial. And then this will be a half times 3 pi over 8, because this root pi and root pi gives us pi. And then 2 by 2 by 2 is 8, and then 6. So we'll have 1 over 2 times 3 pi over 48, which will be 3 pi over, so 2 times 48, so 3, 1, 3, 16. So this will give us pi over 32. So therefore, integral from 0 to 1 of x power 4 square root of 1 minus x squared dx is given by pi over 32. So this is the final answer. So this is the final answer. So in a similar way, try, so as an exercise, use beta function techniques to evaluate or let's be just to evaluate integral from 0 to 4 x cubed divided by square root of 4 minus x dx. Let me give you the answer in advance. So you should get that the answer is 4096 over 35. So play with this one so that you end up with 4,006 over 35 as your final answer. So thank you.